Hi, today we present BlazePose GHUM Holistic, a pipeline for real-time on-device 3D human landmarks and pose estimation, explicitly designed to enable motion capture applications like avatar control, fitness tracking, and AR/VR effects. As part of our solution, we update BlazePose model to predict 3D body landmarks, extend pipeline with 2D and 3D hand tracking, and obtain higher-level semantic body representation via joint rotations, all from a monocular RGB image right on user's phone or in browser. To acquire 3D ground truths, we feed 3D human model called GHUM to manually annotated 2D landmarks. GHUM is created from millions of real-world human scans with wide range of body movements, which makes fittings realistic. One problem is that several different poses in 3D can result into same 2D projection. To avoid this uncertainty, we use depth order annotation, which is highly consistent and reduces error from 25 to 3%. Based on acquired 3D data, we trained and open-sourced several versions of the model that provide various levels of trade-off between accuracy and on-device inference speed. To track hands, we use body landmarks as prior. From 4 parking points, we get approximate hand location, refine it with dedicated recrop model, and then predict 21 landmarks using MediaPipe hand model, which we updated to produce 3D output in the same way we updated BlazePose. One of the main benefits of having separate hand model is the ability to obtain high-resolution crops from original image rather than depend on body model input that should capture the whole body, resulting in rather small hands. Other advantages are spatial independence and same accuracy for both hands. And user prior from the body landmarks together with the recrop model allows us to outperform quality of standalone hand tracking pipeline. To obtain high-level semantic body representation, we created a neural network that fits GHUM human model into given 3D landmarks. It produces 26 body and 16 per hand joint rotations and runs under 2 milliseconds on CPU with XNNPAC. As a result, our solution outperforms state-of-the-art methods for monocular pose estimation while running magnitude faster. Our motion capture pipeline can enable applications like avatar control, gesture detection, fitness tracking, and 3D effects for AR/VR. And running on consumer's phone or laptop would vastly democratize the technology for non-professional users. Thanks for your time, and check mediapipe.dev for our open-source solutions and live demos.